Hello there, my name is Rodolfo Mata and I will be presenting about LangChain and Ollama. I've chosen these two specific tools because, well, actually it comes from my work's experience. I see how I can probably use these tools for optimizing certain pipelines or certain processes in the company where I work at. They are I will be demonstrating a similar kind of idea of what I have in mind, and specifically for summarization and integration of different APIs and tools, but at the same time integrating that content for generating some summaries. Now, this is also, of course, related to natural language processing. We will have an input of some audio transcripts, and then the idea is that we will can use that to create like a summary of that event or a description, or use that as an entry point for other tasks, right? And of course, as a business application, so it can also work for personal tools too. um, Now, that's kind of like the end goal. I'll be using two tools, like I said before, LangChain and Ollama. Ollama, the reason I'm using it is because, well, first of all, it's free. You can use it locally in your computer. Of course, you could also swap it for other tools like ChatGPT API or Gemini API, but Ollama, you can run it locally. It's free. There are many models that you can connect, and you don't need a lot of resources. You don't need to have a huge GPU. You can run it in a MacBook Air, as I'm doing right now. And the reason I'm using LangChain is because it has a lot of built-in tools, very easy to set up, and I can quickly get up something running or have like the idea that I have in my mind of how the pipeline would look like setup. I can set up fairly quickly with minimal code, and I can see also it has some visualization tools that I will also share briefly. But okay, let's get started with the Llama, or actually the outline. What in this video we cover, I will first start with Ollama. I will talk about the setup, downloading models, and basically how to use it. Fairly simple. Then Ollama, like I mentioned before, is just this LLM service that I can have locally. But then I will install LangChain, and now after setting up Ollama, I will move towards a Python Jupyter notebook, where I'll be doing the setup of using LangChain, again demonstrating some basic usage as I've done with Ollama, and then I start adding up on top of that to demonstrate the powerful tools that LangChain has, like tools or these separate APIs, how to use prompt templating and summarization examples, and finally a workflow of the idea that I have in mind, right? So Ollama setup, you just have to go and visit ollama.com. The page is very similar to what you see on the right. You just click on download. It will recognize your operating system. You can just download it. In this case, it's a Mac OS computer, so it will download a disk image, a DMG file. You just install it like any other, bring the executable to your applications folder, and should be able to run it. Then after that, you should be able to use it through your terminal, although I think newer versions of Ollama also have a chat that you can run through just clicking on the application. But then, like I mentioned before, a powerful thing of Ollama is that it has a lot of LLMs models that you can download and use. Some of them have applications or specific goals, like for example the Quen 3 coder, specifically if you want to do some coding or use agents or LLMs for coding completion or creating functions, or where you can also have reasoning models like DeepSeek R1, or just general purpose like Llama 3 or Llama 3. And it's fairly easy to just select the model that you want, select the amount of or the distillation that you want, because there are of one model. If you can see in this example, DeepSeek R1, you can see there are multiple variations, and you might not be able to run the version that has 671 billion parameters, but you can definitely run the one that has 1.5 billion in your computer, or if you have a server with not many resources. So that's great. I will walk through that. And actually, let's go ahead and try to demonstrate that. So like I mentioned before, this is the website. You just click download, you download the file. It will open, it will download a DMG file like I mentioned before. You just click on it, and you should be able to run or install the application like I mentioned before by moving it to the applications folder, and you should be all set. I already have it downloaded on my end, so I will skip that for now. But like I said, not difficult. You just double click on the application, so it should set up everything for you. And then after that, actually let me get, well, I just click on models so that we can see some of them. I'll go to a terminal, and in the terminal I can run Ollama list to see, well, actually let's start with just running Ollama to see all the commands that are available for this program. Now I can see the models that I have listed by you running Ollama list. These are models that I have already downloaded, but in case I wanted to download a specific one, so for example, let's say that I see the Llama tree, and here are different versions of it. I want to get the 3.2, for example. Like I mentioned before, there might be different parameters. I want to get the one that has 3 billion parameters. Okay, I copy this tag, then I just run Ollama pool, and then the specific tag. I already have it downloaded though, but why not? Let me just run it. It should look exactly like this. Then I can, even if I don't have it downloaded, I can just type Ollama run, and it will download and run the model if you don't have it installed already. And then you can use it through the terminal. It's pretty easy and pretty fast, again, if you don't have that many parameters. We'll just type hello there, and it's responding. As you can see, doesn't take long. This is a MacBook Air, so it's not like you need a lot of resources. Llama makes that great, it gives you that great advantage. Everything is optimized and compiled to be able to run with limited resources. Now again, I have multiple models here. You can use them through your terminal. You can also use the API, because once you have it running like I have right now, it will open a port in your local host, and you can make API calls. All of that is documented in Ollama, but I won't get to that. I just wanted to demonstrate how you can run it through your terminal. Now we'll close this, and that's done. Now let's see how we can use this tool to kind of automate all other processes, right? And for that, let's get back to presentation. I was just showing how to use download and use the models. But now let's go into LangChain. That's the second part of this presentation. I will quickly go through how to set it up and use the different tools that I have, that it has, and demonstrate it through a Python notebook. Okay, so okay, let me close this up. I'll close that later. So in here, this is a small notebook that I have set up. It's using the same Python environment that I have locally, so there shouldn't be any difference. Oh, well, I created a virtual environment, but what I meant is that it's running on my computer, so I can make calls to that Ollama service that I have running locally. Okay, so I first have to install LangChain and LangChain Ollama. If you want some basic usage, you're more than enough with LangChain Ollama. I've used it just like that and it works. But if you want some of the more advanced features like the workflow, you will probably want to download LangChain. So first I install it, just like you see here, runs without problem. And then after that, let's see some basic usage. So I am importing the chat Ollama object from the LangChain Ollama's package. And first I just want to create an LLM or model object so that I can interact with it. In here I have to specify the model that I want, and again for this you have to make sure that you have it downloaded. So if I run Ollama list in my terminal, it has to be one of these models. In this case I'm running the Llama 3.2 and the 3 billions parameters model. You can select another one. Let's say for example I want Gemma 3.4 3 and 4 billion parameters. So I'll update this parameters right here, and then I'm setting up the seed equal to 0 so that way you can replicate it. If you copy the same code on your end, you should have the exactly same output. So I'm removing that randomization of LLMs that sometimes even with the same input you can create different outputs. That's basically it. Then I specify two messages, a system message and the human or user input. So I am just telling the LLM, hey, you're a funny coffee shop owner. That's all. And then a user or client comes and say, hello, how much is a latte? Okay, let me just set this up fairly quick. And there are other parameters that I have documented right here that I just wanted to briefly talk about them. There are certain models like DeepSeek R1, like this one right here, that do have it does have capabilities for reasoning. So you can control the level of reasoning, like low, medium, high, or completely disable. You can control the context window, but for example, in this case, I think the default is 2048 tokens, but you can set it up to the maximum of the model. So for example, if I do Ollama show, and in this case I'm running Gemma 3, 4 billion parameters, here context length, this is the amount of tokens that you can set. So I can for example, instead of the default that's 2048, if I'm not mistaken, I can do num ctx and set it like that, so that I have a much bigger context window in case I have a lot of input. But nonetheless, that also means that you will use more memory. It can run on a computer like this, but it does take more time, probably because it's loading and unloading memory blocks on the from the virtual memory to this to the RAM. So just keep that in mind. If you don't have a lot of memory, that might make it a little bit slower. The test that I have done, sometimes it takes up to 6 minutes if it's a lot, but it can still run. It's not a CPU, it's just this memory utilization is a lot. You can control the numbers of GPU. By default, if you're running macOS, it's just running through the Metal API. But you can also set it up to 0 and choose how many CPU cores you're running. You can select how many tokens you want it to predict, and these last three variables control the creativity of the model. If you want it to be very creative, you probably can set up the temperature really high. If you want it to be more concise and not go beyond what's given, then you set the temperature to 0. All of that is documented though in the LangChain documentation. If you go to the docs, and actually you'll have to look the LangChain chain Ollama chat probably. Yes. So I'm sure this is not exactly what I wanted, but yes, basically just look for the specific models right here. You can set up, for example, the chat model providers that it has. If I am using Chat Ollama, you can look for specific parameters right here. LangChain Ollama. Oh, yes, just Chat Ollama, the object that I basically used a moment ago. And if you check here, tab K, tab P, and here are the parameters and the values that it allows. And like I mentioned before, it also has temperature right here, how creative the model will act. But tab K and tab P is basically similar value. You want to use those three together. And again, this is reducing the probability of generating nonsense. That's tab key. Tab A, it's if you want more diverse tags, or it doesn't matter if it's kind of the same and conservative. There are others that it can also control whether it's repeating a lot of things like this, and you want to create a penalty for that. But again, this is great because that means you can control these little options, fine tune the LLM to specifically what you want. In this case, I will leave all to the defaults, and I just want to demonstrate how to communicate with the model. But just know that it's possible to control those options. So I mentioned about the messages, and then I will just invoke the model. It usually takes in this case, not a lot, but like 6 seconds, 7 seconds, but usually it's at the beginning it takes longer because it's probably turning up the model, loading into memory. But if I do right now, it took 10 seconds. If I do a subsequent call, because it's in memory, probably it will probably be much faster. Or maybe not. 9 seconds, slightly faster. Then I'm printing the output right here, and it says, I just ridiculously oversized like class perch on my nose. peering over the counter with a wide, slightly frenetic smile. Well, hello there, sunshine. Let's talk about lattes. They are an investment, a beautiful, creamy, caffeinated investment. And you can see how it started like answering the user's question. It says currently a classic latte is $5.50. Of course, this is just generating it out of nowhere because we don't have information about how much a latte costs. I'm using these specific functions to display in Markdown because the output of these LLMs is usually in Markdown format, but I'm just printing it so that it's easy to go through. Okay, so that's the basic usage. Again, we can easily set up some questions and system configurations. Now let's go a little bit more into tools. What happens if we want to know the price of that latte, or if we have a menu that's changing? Maybe there is an API that we can use to communicate with it, or maybe there are other things that we need, like an example that you can see easily in the LangChain website is the weather. Maybe there is an API for weather. Maybe there is an API for something else that's completely different. But so for that, you will need to use the LangChain base package to be able to add like these extra features. And for example, here I'm defining one function, get coffee price, and you just have to give the name of the coffee. In this case, it will be a latte, and if the coffee is latte, then it's 250. If it is a mocha, it's 4. Just giving an example. And basically, what I do here is, again, I create a model, Ollama chat model, same model. I'm using Llama 3 in this case. That's what I had initially in the example. And then I create a model with this object, with this function, and I provide the model. I provide a tool. Note that the tool does have a description doc string. It's important to have it to describe what your function is doing. And then I add the system prop separately. You are a funny coffee shop owner. Okay, so I set this up. Runs pretty quickly, and then I invoke the agent. That's an agent, and invoke it like this with the message of the user. Say, hello, how much is a latte? Basically the same question that I had before, right? Hello, how much is a latte? Yes. But now let's see what the response is. And something that I also probably didn't touch much on before was the format of this response, or the object response. It not only contains the actual output of the LLM, but it does have other parameters. For example, right here, you can see that it has the messages component that has like a list of like these interactions. Right now, the human on the input was hello, how much is a latte? But then it goes through the LLM without any output, probably recognize that it does have to use the API. Then it called the tool, the get coffee price, and he recognized, okay, the content is 250 because it's a latte, what we're looking for. Okay, and then it does use some language process to be able to recognize what you're asking for, and then that sends that back to the AI or to the LLM. The LLM generates a response now with that information. Oh, our lattes are a great way to start a day, and they're only 250. So now let's actually check. I'm gonna check the response just as I did before, but notice how now I query the response slightly different. I go through messages and I am looking specifically for the third output of the context, because there is like this like kind of pipeline of calls, and I get specifically the content of that message. But notice also how you have all other data, like the model that you use, when it was created, the duration, if you wanted to have some performance, the amount of tokens that you use, the output tokens, total tokens used. So in this case, we're using 130. That's almost nothing, right? And again, here's the output. Our lattes are a great way to start your day, and they're only 250. Would you like to try one with us? So that's a pretty simple demonstration how we can use this kind of API and integrate it with this LLM questions to have more accurate answers, right? Maybe this changes every day, the menu, and in that case, you can have an API that just query the menu for a specific latte, and it returns the specific price, right? And this is just a conversation that you're having with LLM. Pretty cool. Now let's talk a little bit about prompt templates, and this will be useful for the specific use case that I have in mind of grabbing this transcript of like a meeting. So In this case, I'm setting up a little bit different. The user is saying, hello, what kind of coffee would you recommend? And here is the system prompts, still the same. You're a funny coffee shop owner. And then here is the input template. Greet the clients with a motto, our coffee is groundbreaking. And the customer message. This message should be what the user is inputting. So all of this will usually stay the same, and this will change based on the user input, right? So you keep that in mind. I configure or format the input with the specific message that I had in mind. I build again the package of the messages, and I call the model, just like I did initially, very basic. I just call the model, and let's see what the reply is. So, glad you asked. Our coffee is groundbreaking, get it? But seriously, we have some amazing blends that just might blow your mind. So again, in here, you can see how it is taking some of that context. But the reason why this templating is useful is because sometimes you might want to combine different things in your input command, right? So and that's exactly what I want to do next, actually, as we get through the summarization. So in this case, I have one video that it comes from IEEE Education Society and the YouTube channel right here. So I was able to get the transcript of this video, this kind of DemoCon 2025, and they're having their opening and stuff. And this was originally a Zoom meeting, and as you can see, like say virtual. So this is a transcript. I have it downloaded right here. You can see like say virtual. This is basically the transcript of that meeting. Now this is the whole event, right? So in here, I'm trying to first get that transcript. You can get transcript. You can get probably have other services, but the point, the example here is that from a meeting or a webinar in this case, retrieving the transcript. Okay, I have it right here. It's the same transcript. Okay, and what I want to do is basically give this LLM or agent this transcript and ask the LLM agent to create a summary. So okay, system prompt, you're an eloquent reporter, create a summary, and this is the input prompt, create a summary of the meeting using the transcript provided. And here is a transcript. I'm loading into the same prompt, so you see I'm doing this kind of templating, and I just format it here, again build a packet for the message and send it to the LLM. Display the output. Let's see what it gives back to us. And right after this, we're getting into the last section of this demonstration, how to use LangChain. And I'll be talking about the workflow and how we can use these kind of pipelines to build something slightly more complicated. Maybe we want to get the same transcript, and what if we want to create like not only a summary, we want to define a topic, but then we want to use this to create like a post in X or Twitter, well, X, previously Twitter. And what if we want to add also a description for the YouTube video? So for example, if we had the YouTube here, to create like this kind of description right here, right? Okay, we will go through that in just a minute, but see how in here this text appears to be a transcript of a presentation or discussion about the artificial intelligence in education, specific in the concept of massive open online courses MOOCs. The speaker discusses the potential, and he's talking about slightly about what they talked about in the video. In fact, it's about AI in digital and open education, and they do talk about this massive open online courses. So it's interesting to see that yes, it can catch information from those transcripts and create and generate this summary, right? Great. So now let's walk down the workflow, and for this now I'm defining again the same object, Llama an LLM with the same Llama 3 model. Again, the same seed. I'm not touching on other parameters, just the default. And now here I'm doing something slightly more advanced, and I'm using Lang graphs. You can see those in their website. They probably have right here, Lang graphs, and that's basically to allow you to create a bunch of other things, but I'm specifically talking about workflows and agents, so that we can not only have this simple prompt, but we can do something more like, oh, maybe we get the input and then there is one agent that will do something with that and transform it into something that then we will send to other workers or or LLMs. As an example, can be when you have a whole building pipeline, instead of just providing the code and, or sorry, providing the idea, like, oh, what happens if you want to have like this developer, instead of just asking, hey, can please create a web app that it's for a chat, an online chat. Instead, you can have one pipeline that has like a design, a front end, a back end, and just send it through different LLMs and services, right? So in this case, it's something simple. I'm still working with this transcript that I talked about. And what I want to do is basically first identify the topic of this transcript. Then I want to, with the topic and the transcript, create a summary. And then that summary and the topic, I want to use this to do two things: create the YouTube description, but also create a Twitter post. Okay. So for that, I first define a state. These are going to be like the different inputs and outputs of this pipeline, so that I can see what's going on. This originally the only thing I have is the transcript. That's the input for everything. I define the output, and just like I said before, we have to add these descriptions for these functions, these doc strings. And I talk, okay, well, I invoke the LLM and say, hey, I provide the transcript starting, and I say, hey, please generate a single topic for this meeting, see the above transcript, and the topic, and I wait for it to generate the topic and save that into the state. So now I will have the transcript and the topic. Then I do the same thing in summary, but notice how I provide the transcript and provide the topic and ask, please generate a summary, and get the output and save it into the same object state. And I keep I keep doing that for the other two stages, and these two stages are supposed to run in parallel. So I have the YouTube description and the Twitter post, and for both I use only the summary. I don't use the topic, just a summary. Okay. So I define those functions, and this is basically defining kind of those edges as a graph. It starts with the generating the topic, then from the topic goes to summary, then from the summary goes to these two functions, and then it ends. Those two lead to the end. I compile the object, and this is the cool thing with LangChain. I can generate this flow of how things are actually running. And look, it's right here. It starts, generate topic, create summary, goes through both things, and that's the end of it. So I compile it, and I can use it now. And now look at how I invoke the workflow. I provide just a transcript, which is the same object right here, transcript. So I just provide the transcript and then run it, and then I will get the output state. The output state will be the same object with all the other parts filled. As an example, I will be just printing just the output of the YouTube for the description, and the output of the Twitter comment. These two basically, but you can print all of it. And the interesting thing is that you can even define some conditional branches. So sometimes you might want to add an extra field only if certain other things happen, like for example in this coffee shop example, if the customer is asking for the price of a coffee, then maybe we call this other tool and do something else. But if not, then just say hello and be friendly. Just an example, right? So okay, after that runs, let's call and print the output of those two, and that shouldn't last much longer. The cool thing is also that parallelization work, so that when you have multiple pipelines, you can make sure if your computer has enough resources, you can take advantage of that. So right here you see the YouTube description, you can see title. I generated some title, so honestly, it seems to be made up. I mean, it's still within the range of what the presentation talk about, because it does talk about artificial intelligence in education, but it generated a title. It does give a description, and it says, oh, follow us, and then the YouTube channel name plus the subscribe button and the speaker and some more information. For the same output, for the same video, it generated a Twitter post or X post. New video alert, join this speaker from this university as he discusses the future of AI in education and governance. So as you can see, and as I have demonstrated, we can use this tool to kind of create these very complex pipelines. Well, I hope you have enjoyed. Thank you so much for watching.